Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Another installation about this body, ball, rock, cannonball, whatever, that has been thrown with initial speed v0 under the angle alpha and it travels, and we need to find, this time they ask us to find the trajectory. What is trajectory? They want us to find the trajectory. So let's do x at any given moment of time is initial speed, which is this, v0 cosine alpha multiplied by t. Indeed, if t is 0, it's located here along this axis at x. And of course, if t would be this, it will be here. But any given moment, it's described with this formula. Y is, we travel in this direction with initial speed this. And this is positive and this is way. v0 sine alpha multiplied by t minus, because acceleration is down, gt squared over 2. And those are two formulas that describe our trajectory. And you may see, what about t? And this is called parametric expression for trajectory. Because t is a parameter, v0 alpha, those are fixed, but t is changed. This is a parameter that changed. And at given moment we can know x t, it's somewhere here, and we know yt, it's somewhere here, and we know that the body is here. So we know the point where the body is located, right? We know x and we know y. Okay, but let's forget now about this. I will be writing simply x and y. And let's exclude this t, because if I look here, I have x, I have y, and I have t. Three things and two equations. So I can get rid of one, and this one would be my t, my parameter. I will get rid and I will have expression that will contain y and x. And we will see what it is. So it's very simple to find from here. T equals x, and this goes to the bottom. v0 cosine alpha. And of course I can plug it in this, and I have y equal v0 sine alpha multiplied by t. T would be x, and there would be v0 cosine alpha. And I plug this here, minus g over 2, and then I have to plug this. So this would be, I'm plugging this here. This would be x squared, and this would be v0 squared cosine squared alpha. And so this is expression that contains v0 alpha, and it defines me how y depends from x. X, I excluded t, so I have dependence y over x. So y is dependent like this, and I can write it in a more simple way if I want. I can say y equal tangent alpha x minus g 2v0 squared cos squared alpha multiplied by x squared. So what I get here is that, let me wipe it out. I want to keep this though. So I will wipe out this, because this is the expression that a parabola, if you look at playlist, algebra. There is like 6 or 7 installations about quadratic functions and the parabolas. And if y, alpha is fixed, v0, g, it's all numbers. But x is function, so y depends on x squared, and x and no c, abc, ax squared plus bx plus c. So this is a parabola. The branches of parabola are directed down because this is minus. And also we can easily find the roots of this parabola. But let's say I will repeat this when I remove this, and I will start writing here, and I say y equal ax squared plus bx plus c. This is a canonic function, polynomial of second degree, and I immediately see it here. I see that this is minus g divided over 2 v0 squared cosine squared alpha x squared. So I know that this expression is a, and I know that it is negative, and that means that branches of parabola are directed down. And then I have plus tangents alpha x. And so tangents alpha is this b, and this one is this a. So I know that this is a parabola, I know that it is directed down, and let's find the roots of this parabola. Roots means where y equals 0. And y equals 0 means this point and that point, right? And for example, if I put 0 and switch it, so get rid of the positive numbers, so I move this to this, I will receive g2v0 squared cosine squared, right, x squared equal, and tangents I write again sine alpha over cosine alpha, again back and forth, multiplied by x. This happens when y equals 0, I put 0, then I move this to this side, and I left with this, there is no numbers. And of course I have two solutions. One solution, x1 equals 0, and it describes me this point. And of course, if I divide on x, I can divide easily if x not equals 0. I receive gx 2v0 squared cosine squared alpha equal sine alpha cosine alpha, right? And then I can find another x. I send this to here and this to here, and I receive x2 equal 2v0 squared sine alpha, this cosine squared alpha, and in the bottom it would be g goes here, and there was already cosine. Okay, so one cosine will go away, and x would be 2 sine alpha multiply cosine alpha multiply v squared g, v squared over g. And if I have 2 sine alpha cosine alpha, it's exactly sine of 2 alpha. So I have v0 squared sine of 2 alpha divided over g. So I have this formula that describes me the full parabola, and I obtain the distance L, because L is exactly this x2, this is L, and I obtain this directly from this parabola. Okay? And what else can I do? For example, if I put x equal L divided over 2, and I plug it here, so this distance, I will plug it, so I wipe it out, because nobody needs it. This is just... And I want to see on this graph, what is the multiple height, maximum height. Maximum height is here. It is when x equal L divided over 2. This is this point. I plug this number here, and I should receive the h, which should be like this, right? So let's try to do it. So I say y, and it's not y, this is h, because this would be height, minus g divided over 2v0 squared cosine squared alpha, and instead of x I put L and over 2, and I will use the different formula. I will use this 2 sine alpha cosine alpha. I take it back, cosine alpha v0 squared over g. So this is what I do. I put L over 2, this would be 2 would be gone, and this would be v0 squared, right? It looks scary, but everything should cancel out itself. v0 squared sine alpha cosine alpha, and this would be squared because of this square, and the bottom should be g squared, and this is the first part only. And then I have to put plus this tangent alpha. Tangent alpha would be sine alpha over cosine alpha, right? And x would be L over 2, so it would be sine alpha cosine alpha v0 squared over g. So let's see what happens with this, and I don't have room for this. But okay, let's remove this, and I will write it here. So this would be minus g, this g and g would be gone, right? This would be minus v0 squared would be v0 to the fourth sine squared cosine squared divided over 2v0 squared cosine, this would be sine squared of alpha, cosine squared of alpha, and this would be g, right? This I dealt with this. Now let's deal with the other one. Cosine and cosine would be gone, v0 squared, so this would be plus v0 squared sine squared divided over g. Okay, let me wipe it out, and let's continue because everything should be fine. So we have h equals v0 squared is gone, and this becomes v0 squared only. v0 squared, cosine squared is gone, right? And this becomes 2g, right? And minus, don't forget this minus. So this becomes 2g in the bottom. That's all that left from denominator of this beast. And here I should put sine squared of alpha. And this is plus this one, v0 squared sine squared alpha divided over g. And basically I have 1.5, so 1 minus a half, so I have h equals the same expression, which is this and this, so I have v0 squared sine squared over alpha divided over 2g. And if I look, I got the correct thing. So, before I got h just analyzing the independent movement on this direction. Here I got the formula for the trajectory, and this formula was a quadratic function, and the graph of this quadratic function was a parabola, and branches were directed down, and so this is an apex, and the axis of symmetry is between this root and this root. So I found this L, I found this X, I divided it in half, and I plugged this number X that you can follow, and it will be a very good exercise if you can follow these cumbersome expressions. But we came to the correct answer, so I made no mistake this time. So you plug this L over 2 into this formula of parabola, and you get this y, and this y became this h, and h becomes this, and this is exactly what it is. So case closed, and I will continue with this cannonball or baseball or whatever flowing in different circumstances, because this is the subject of this two-dimensional kinematics. If you liked it, like. If you want more, subscribe. If you want to be notified, bell after you subscribe. And question, comment, problem, put it in. Thank you.